Hello and welcome to heat transfer lab. In today's experiment, we will perform heat transfer in laminar flow. This is the experimental setup. In this setup, there is a heat exchanger, double pipe heat exchanger. Also, we can say concentric tube heat exchanger. In this heat exchanger, hot fluid is sent in the inner pipe. Just so this. The hot fluid is sent through this into the inner pipe. Cold fluid is sent in the outer pipe. For the cold fluid, we use tap water. This tap water goes to the rotameter. Then it enters to the heat exchanger in the outer pipe. For the hot fluid, we use water, heated water. This is the storage tank for the hot water. Inside this tank, there is a heating coil which is used to heat up the water. This is the parallel flow heat exchanger. There is one other type which is known as counter current heat exchanger. But in our setup, this is the co-current heat exchanger. So both fluids enter from the same side. Edging for the both fluid is same on the other side. This hot fluid is circulated through the pump to the valve, then it enters the heat exchanger, then it exits from the other end, it goes to the cylinder, then in the end it goes to the storage tank again. It's a complete circuit for the hot water. For measuring the temperature, we use a temperature indicator. There are 4 readings, 2 for the inlets, one for the cold water inlet, one for the hot water inlet, 2 for the outlet, one for the cold water outlet, other one is for the hot water outlet. For this, there are 4 thermocouples which measure the temperature. This is the outlet, hot water outlet. This thermocouple is for the cold water outlet. This thermocouple is for the hot water inlet, and this thermocouple is for the cold water inlet. All readings we can note down from here. And this is the controller where we set the desired temperature. Using this cylinder, we measure the volumetric flow rate for the hot fluid. The volumetric flow rate for the cold water is measured using this rotameter. And in general, we keep the flow rate above of the 100 lph. The reason is that when we keep a very small flow rate, then there will be fluctuation, and when we keep a very high flow rate, there will not be a significant temperature difference. So therefore, we keep around 100 or 110, 20, 50 somewhere in that region. For the hot water, we measure the volumetric flow rate using this cylinder. The reason is that rotameter cannot measure the very low flow rate in the laminar region. Therefore, we use this graduated cylinder. Now come to the process. Overall process is very simple. First, we need to set the desired temperature from here. Using this screw, we can set the temperature. Right now, it is at 70 degree. We have set it at 70 degree. Once temperature reaches at the desired set value, we just open the valve for flowing the cold water. Then just start the pump from here for flowing the hot fluid. Next, we need to open the valve from here. So this hot water enters in the inner pipe, exits from the other end, it goes to the cylinder. Now it is coming. Then it will go to the storage tank. Before measuring the volumetric flow rate, it is always advised to wait for some time so that system can reach the steady state. Otherwise, due to the temperature difference, there will be some significant difference in the viscosity that can affect the flow rate. Note down the volumetric flow rate of the cold fluid. Then stop this. Note down the time until this place. Then again open this. Repeat this experiment at least 3-4 times so that you can have average value plus error. This is the hot water inlet temperature. For the hot water outlet temperature, we can measure from here T1 first reading. This is the hot water outlet temperature. Just wait for some time. Next, we need to note down the cold water inlet temperature. Then cold water outlet temperature. Alright, now we'll change the flow rate of the hot fluid. From this valve we can control the hot flow rate. Again we will wait for the steady state, then we will stop this and we will note down the time up to this place. So this will be the second reading. Accordingly we will note down the all 4 temperatures. For the cold fluid, flow rate is kept constant. Similarly we will do 3-4 readings, 3-4 different flow rates we will use, and we will note down this time and all the temperatures. After that we can calculate the overall heat transfer coefficient as well as individual heat transfer coefficient for each side of the fluid. So details about the calculation we will see later.